Hey guys, this is Miss Peters. I'm going to go over how to do the light calculations for the flame test lab. Now, before I get started with an example, we have two equations with light. One of them is C equals lambda times velocity, this one, and really fast are variables. C is the speed of light, which is 3 times 10 to the 8 meters per second. Lambda, the upside down y, is your wavelength. And our wavelength always has to be in the unit meters because the speed of light is meters per second. So I'm going to put meters in parentheses. And then V is the frequency. And then our other equation for light is E, energy of a light wave, equals H times V. So E is how much energy any wave carries, any electromagnetic wave. H is a constant, so 6.63 times 10 to the negative 34. That's called Planck's constant, and it is just a constant. It's always that value. And then V is your frequency. And so what happened with the flame test lab was we burned chemicals. I put them in the fire. Whenever I put them into the fire, the electrons got excited. They absorbed that energy and they moved up to higher energy levels. That's called them getting excited. And they took in energy from the flame. But electrons can't stay in their higher energy level. So for example, let's say this electron was originally at like 1s. It maybe went up to 2s. Well, they can't stay excited like that. They have to go back down to their original energy level. And so from its excited state in 2s, it goes back down to where it belongs in 1s. And when it does that, it has to give off energy. And the energy is given off in, for this lab, the case of visible light. And that was the colors that you see. And so energy is given off as light. And so I'm going to completely make up a number. This isn't even a wavelength for visible light, so this should not be an option for any of your colors. This is just an example. Let's say that, and so you looked at, after I burned the chemicals, you wrote down the color, and then you went to your electromagnetic spectrum, and you estimated the wavelength. And let's say you estimated the wavelength as 900 nanometers. Now remember, that is not even an option because 900 nanometers is not visible light. But the equations still work the same. So I'm going to go through what I want you to do on the flame test lab. So 900 nanometers, that is our estimated wavelength. That is the upside down y, lambda. I wanted you to find the frequency and the energy. So we have wavelength. We're going to have to use the equation C equals lambda V because that's the only equation that has wavelength in it. Energy does not. And so I have my wavelength. I know what C is. C is 3 times 10 to the 8 meters per second. And I'm looking for frequency, which is V. That is my unknown. Now, hopefully something in your brain will look at wavelength as nanometers. It has to be in meters, and so we need to convert that unit. And so to convert from meters to nanometers, the conversion is 1 meter equals 1 times 10 to the 9 nanometers. So nanometers are super small, smaller than centimeters. And so our pretend number is 900 nanometers. And we need to change that to meters. So 900 nanometers, set up a dimensional analysis, and because you need to get rid of the nanometer unit, we're going to put 1 times 10 to the 9 nanometers at the bottom. And that equals 1 meter. And then when you type this into your calculator, I've had a few people message me that they're not getting their correct wavelengths because they're typing it in wrong. So if I were to type this in, what I would type is, and I'll just write it underneath, right here in brackets, 900 divided by, and I told you before, anytime you use scientific notation, put it in parentheses. So parentheses, 1, the E button, 9. Close your parentheses, hit enter. Okay, so you can type it in like that. If you don't have the E key or you don't know how to use the E key, another way you could type it in, I'm going to put that in brackets. So these are just examples how you should type it in the calculator. 900 divided by, open your parentheses, 1 times 10, you hit the caret button, 9. Close. And that should give you this number. And then you can leave it like that, or you can change it to scientific notation, whatever you prefer. I don't like writing 6 zeros, and so I'm going to change that to scientific notation, and it should be 9 times 10 to the negative 7 meters. So now my wavelength is in the correct unit, and I'm going to write that off to the side over here. 9 times 10 to the negative 7 meters. So now I can solve for frequency because I have my wavelength in the correct unit and I have my speed of light in the correct unit. Okay, so the equation is C equals lambda V. So my C is 3 times 10 to the 8 equals my upside down Y, lambda, is 9 times 10 to the negative 7, and then times V. So I'm trying to solve for V. To get V alone, or my frequency, I need to divide each side by 9 times 10 to the negative 7. And when I do that, I get V equals, and make sure when you type this into your calculator, type in parentheses 3 times 10 caret 8, close, divided by parentheses 9 times 10 caret, make sure you use the negative symbol, not the subtraction, negative 7, close. And so let me type that in really fast. That gives me a frequency of 3.33 times 10 to the 14 hertz. And I'm going to circle that because that's one of the values that I'm looking for. Now, I also wanted you to find the energy. The equation for energy is E equals HV. E is energy, what we're solving for, so I'm going to leave that. H is a constant. Remember, it is always this number, 6.63 times 10 to the negative 34. So 6.63 times 10 to the negative 34. And then V is frequency. We just solved for frequency right here. So I'm going to use that value, 3.33 times 10 to the 14. And I'm going to type it in just like that to solve for energy with parentheses around both of my scientific notations. And so let me type that in. And when I type that in, the energy of this wave is 2.21 times 10 to the negative 19, and the unit for energy is joules. And that is what you're going to do for the flame test lab for every single chemical. You're going to solve for their frequency, which is V, and then solve for the energy, which is E. And then you are going to go take the conclusion question quiz on Canvas. It's 4 questions and it's worth 40 points of your lab grade. So I hope this was helpful. If you have any questions, please message me, and it helps if you will message me with a screenshot of or a picture of the work you've been doing. Otherwise, I can't really figure out what's going on. And again, this is due tomorrow, Thursday at 7 a.m. Good luck!